All right. Hi. So in preparation for your test or exam paper 1 for June, we'll be going through this question today. So for the first one, this is just a question 2 from one of the past papers. We are told that the volume of a cone is given by this equation. So we're having V, it's equals to 1 over 3 pi r squared h, like that. This is the formula for the volume of the cone. They're not expecting you to know that or memorize that. So this is what you have. So supposed to write down the value of r, which is the radius of the cone in terms of these over here. So what they're asking you to make r the subject of the formula. So they're expecting you to end up having something like r, it's equals to blah, 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 right? So in order to do that, we'll just say V over here, it's equals to 1 over 3 pi r squared h. So remember, all of these things are being multiplied with r. So if you're having something like 4a equals to 1, and you're looking for a, since these two are multiplied, you will divide by whatever that is multiplying the a value, which in this case is 4. So that means for this side, you have to divide by whatever that's multiplying this r squared. So to simplify things, we can first get rid of this 1 over 3 by multiplying by its reciprocal, which is 3 over 1 both sides. So multiply by 3 over 1 both sides, we end up with 3v. It's equals to pi r squared h. Then we try and get rid of this pi and h value. So we divide by pi, we divide by h. So this pi cancels that one, h cancels that one, and then you end up doing this on the other side as well. So at the end of the day, you're left with r squared. It's equals to 3v over pi h. And then you're searching for r, not r squared. So to get r, you just have to apply the square root, like that. But remember, whenever you apply the square root, there's always a plus minus value that comes with a square root on the other side. So this ends up being r, it's equals to plus minus the square root of 3v over pi h. But we will take the positive value of this since we cannot have negative radius. So that means this will just be the square root of 3 over pi h, like that. So this is what we were supposed to do. So for 2 marks, you could have skipped a few steps, but I added these other steps so that you see what really happened. So we multiplied by this inverse to get rid of this 1 over 3 over here. And then whatever you do on your left, you also do on your right. Yeah, so this is what you're supposed to do for 2.1. Any questions for that one? Okay, I'll assume silence means everything is okay. All right, let's see what we have next. For 2.2, we are given this, whereby we are supposed to solve simultaneously for x and y. Supposed to solve simultaneously for x and y. This is for 4 marks. So whatever method that you understand better, whether it's substitution or elimination, you're going to apply that. So we're solving for x and y. So let's look at this using both methods. So here we'll use elimination. And then here we'll use substitution like that, right? For elimination, remember the goal is for us to get rid of one variable. So here I have 3x equals to y minus 4. The other one is 2y equals to 5 plus 3x. So what I usually do is to put all the variables on one side. So for this one, I'll have 3x minus y, it's equals to minus 4, like that. For this one, I'll have 3x, so it's going to be negative 3x plus 2y, it's equals to 5. So these are my new equations like that. So we try to get rid of one variable. So the easiest one we can get rid of here is this one over here, which is 3x. So it's 3x and 3x. So to get rid of this, we can just say this one minus that one. So if this was our equation 1 and this was our equation 2, we can just say equation 1 minus equation 2. So we'll end up with 3x minus, actually it will be plus. It will be plus like that because this negative is from the 3x. So it's going to be this plus that. So we're going to have 3x plus minus 3x like that. So these are like terms. So we just end up with 3x minus 3x, and then this ends up being 0. So that means here we have 0, or we no longer have the x variable. And then from there we have minus y plus 2y. So these are like terms. So what will happen is these are like terms. So what will happen is we just take the coefficient, which is minus 1 over here, and then plus 2. So it's minus 1 plus 2. This ends up giving you positive 1. So this is just y. So here you'll have y. It's equals to, this will be minus 4 plus 5 over here. You end up getting this as positive 1. So this is 1. So this is very much simplified. You just have to conclude that y is equals to 1, like that. So after concluding that your y value is equals to 1, you can substitute this y value into other equations. So you can plug it back here, you can plug it back here, as long as it's simple for you. So you'd end up having, let's use equation 1. So sub into equation 1 over there. Even if you can make this 1, 2, and then this make it 3, and then this make it 4, it's still fine. So we can say sub into, let's make it like this. Let's make this 3, let's make this 4. So we said 3 plus 4 like that. So sub into, let's sub into 3. So this will be 3x. Wherever I'm going to see y, I'm going to plug in 1 minus 1 like that equals to negative 4. And then I'm going to have 3x equals to minus 4. This is negative 1. When it crosses over, becomes plus. So I end up with 3x, it's equals to minus 3. I divide by negative, divide by 3 over here. I divide by 3 over here. So I'm left with x, it's equals to negative 1. So therefore, it means that my x value, it's going to be negative 1. My y value, it's going to be 1, like that. That's my solution. So remember, I said that all the time for these questions of solving for x and whatever, you try and plug back these solutions to your original question. So we can start, which equation didn't we use? We didn't use 2. So let's see if we're going to use this into equation 2, if we do get the left being equals to the right. So the left-hand side is 2y, it's equals to 5 plus 3x like that. So if I'm going to substitute for y, 1. So for left-hand side, if I'm going to substitute y being 1, that means I'll have 2 times 1 like that, and then I'm going to get 2. So I'm expecting to get the same thing on the right-hand side. So right-hand side, I'm going to have 5 plus 3. My x value was -1. So if I plug in -1 here, I have 5 minus 3, and then I end up getting 2. So my left-hand side is the same as my right-hand side. That means I can confidently say that my values are correct. Like that. Any questions on that one? Any questions? All right, I'll assume that people are silent because there's no question. Right, next question we are given is this one. So this question on your pages from, I think, the 13th, it's on part A, from the 13th, so 13th of May. So it's part A, question 2. Right, so for question 2.3, we have done these two. Question 2.3, we are asked to solve the following inequality. We are given -3 is less and equal to 3 plus 2x, which is less than 13, right? So I'm supposed to solve for this inequality. Afterwards, supposed to illustrate or show your answer on a number line if x is a real number. So here they're trying to see if you know what a real number will be. They're trying to see if you know how to draw your number line. So firstly, let's solve this. So given -3 is less than equals to 3 plus 2x is less than 13, like that, right? So since this equation or inequality is two ways, you have this section over here, and you also have this section over here. So it's two ways like that. So whatever that you would do this side, you also do that side. So this, you would say I'm having -3, it's less than equals to 3 plus 2x is less than 13. So I'm solving for x. So normally if this was an equation, I would be having 3 is equals to 3 plus 2x, and then to solve for x, I'll just take this 3, I'll transpose it to the other side. I'll have -3 minus 3 equals to 2x. So we'll do the same thing here. We are transposing to the other side. So that means I'll have this 3 transpose this side. It's -3 minus 3 is less than 2x. I'll take this 3, I'll transpose it to the other side as well. So I'll have 13 minus 3, like that. So whatever I've done on my left, I'll have to do on my right. So this ends up being -6 is less than equal to 2x, which is less than equals to, I think this is 10, like that. So I'm still solving for x. So if I had this as a normal equation, which is -6 equals to 2x, to get rid of the 2, I'll just divide by 2 both sides, and then I'll end up with -3 over here, it's equals to x. So I'll do the same thing here. Divide by 2 on the left, I divide by 2 on the right. So this ends up giving me -3 is less than equals to, this ends up giving me x, this ends up giving me 5, like that. So I have this in that notation. I believe this is what's called set builder notation. So this is our set builder. Set builder notation. We can have this in another notation which we call interval notation. So for interval notation, we check these signs. If I'm having this equal over here, that means I'm going to have a square bracket. It means that number is included. If I have, I don't have that equal sign down there, that means I'm going to have a round bracket. It means that number is not included, like that. So to write this in interval notation, we would write it like this. They didn't ask that, but just in case you do get a question that asks you to write your final answer in interval notation, since this -3 is included, we'd have a square bracket over here, -3. Next, since this 5 is not included, we'd have 5 and a round bracket like that. And then we'd say that I would just say x is an element of this, like that. Right, so this is not interval notation, set builder notation, like that. So we see that our x values are real numbers because -3, -2, -1, 0 up to 5, with 5 not included. That means up to 4.999999. All of those are real numbers. All of those are real numbers. So we can put that in a number line. So to draw our number line, it's simple. Just gonna have a line. We're gonna plug in the two numbers that we have over there, which is -3 and 5, like that. So on your number line, I'm not expecting to see any x variable. So you have those two numbers. Afterwards, on top here, we're gonna have two circles. It's gonna be open if it's like that. So if it doesn't have the equal sign here, if it's not included, then it's gonna be an open circle. If it does have an included sign or an equal sign like this, then you have to shade it like this. So this means that this -3 is included in the numbers that will make this inequality true. Right, then from there, we check over here. We go back here, we're gonna take any number that's from this side that's less than -3. So -5, -10, all of those numbers are less than -3. So we take that number, plug it into the inequality and see what sign we get. So let me see if that will work actually. Okay, that method won't work for this one. But eventually this is what you're supposed to have. Like that. Right. So all the numbers that satisfy this inequality are between here. So the method that I was trying to apply won't work because we have two inequality signs. But if we were using one, then we would have to check what sign will I get if I'm going to substitute -10? What sign am I going to get if I'm going to substitute a value in between here, which could be 0 or 12 or whatever, not 12 or 2. What sign am I going to get this side if I substitute a number greater than 5? So it might be 7 or something like that. Right. So we're going to use that method if we had one inequality sign. So this becomes our final answer. So what we did, we transposed this 3 both sides. We ended up with -3 both sides. We divided by 2 on both sides. We ended up with this. And then here we explained interval notation. We said the square bracket means that this -3 is included in the set. So we include it when we count the values. Hence, we shade our circle. We said this one is a round bracket because 5 over here is not included. That means we are saying this inequality is true for all x values from -3 up to 4.999999999 something, but not exactly 5, not 5, like that. Any questions on that one?
No, sir.
All right, moving on. So 2.4. Let's do this. So 2.4, we are given an equation. supposed to solve for x. So we're given this as 2, use red, 2, the dot is times 3x plus 1, it's equals to 162. Right, so what we're trying to do here, we're trying to solve for x. We're trying to find out what value of x should I plug into this exponent over here, such that my left-hand side will give me 162. So firstly, I'm trying to remain with only this 3 that has this base x, the exponent x. So that means to get rid of this 2, I can divide by 2 both sides, like that. So I have 3x plus 1, it's equals to, what do we get when we say 162 divided by 2? Do I have a calculator nearby? It's 162 divided by 2. So we're getting 81, like that. Right. Next, what we try to do is to change this 81 to have the same base as 3, like that. So to do that, we use what we call prime factors. Right. So those who had in class, I showed them methods to find these factors. If you are using the Casio calculator, you will say 81 and then equals to, and then after that, you'll say shift, and then there's a button that has this fact like that. Can we try doing that? What do we get?
3 to the power of 4.
3 to the power of 4. So that means it matches this base that we're looking for. So it's going to be 3x plus 1 equals to 3 and 4, like that. Right. So now that I have the same basis, what I can do, I can drop my exponents now. I can say therefore, remember these 3 dots, say therefore, x plus 1, it's equals to 4. So first thing I tried to do was to make sure that these bases were the same, and then I equated the exponents. Then from here, I'll say x is equals to 4 minus 1. That means my x value is equals to 3, like that. So what we are saying here is that if I'm going to take my calculator and say 2 times 3 exponent 3 plus 1, I'm supposed to get what answer? What do you get? What do you get?
3.
You're saying 2 times 3 exponent 3 plus 1. What do you get?
Oh.
162.
162. So that means our calculation here was correct. Any questions with that one?
No.
Right. Moving on. Here for 2.5, let's do this. For 2.5, we are told that we have a kite here. The sides of a kite are x squared plus 3. So if we're going to say this is our kite, I can still draw. Like that. We are told that one side is x squared plus 3. The other side is x squared plus 3x minus 3, like that. We're supposed to calculate the value of x if the kite will be a rhombus. So how is a kite different from a rhombus?
The properties aren't the same and they're not the same.
How? Let's talk about sides. What's the difference between their sides? kite has 2 short and 2 long pairs of sides. Like that. So 1 pair that's short, 1 pair that's long. A rhombus has all the sides being equal. So they're saying that if the value of x, calculate the value of x for which the kite will be a rhombus. So if it's a rhombus, that means all the sides have to be equal. So for the sides to be equal, that means this side has to be equal to that side. So to do that, we'll just equate those two. So to say, we'll say x squared plus 3, it's equals to x squared plus 3x minus 3, like that. And then we just solve for x, right? So we can have x squared minus 3x. We can have equals to minus 3. This 3 comes this side, minus 3. So this gives me 0, my like terms here. I'm left with minus 3x. It's equals to minus 6. I divide by minus 3, both sides. I end up with x, it's equals to positive 2, like that. So the value that I have to have for x over here for this kite to be a rhombus has to be 2. So that was my 3 marks. When they say hence or otherwise or any of those terms, they're saying from whatever that you have used or whatever that you have found on the previous answer, use it to continue solving this question. So they're saying hence determine the length of the sides of the rhombus. So if these two are equal, we can say the side of the rhombus will just be x squared plus 3, and then we substitute this x value, which will be 2 squared plus 3. This will give me 4 plus 3. This will give me 7 units, like it. I can use this side, I can use the other side, which was x squared plus 3x minus 3. So here I'll have 2 squared plus 3 into 2 minus 3. This will give me 4. This will give me 6 minus 3. This is 10 minus 3. This is 7 units. So both those sides are giving me the same answer, like that. So the hence part here, it's saying whatever answer I got here or whatever simplification I ended up getting on the previous question, I'm supposed to use it to get the length of the sides of the rhombus. So the length of the sides of the rhombus are 7 units, like that. Any questions there?
No, sir.
All right, should we take in another question or people need to continue studying?
Yeah, so we can take another question.
All right. Let's see. All right, so this is from the 13th of May as well, part D on your pages. So it's trigonometry. Let's look at it. So here we are asked in which quadrant will theta lie if the restriction, if we are told that theta is from 0 to 360 and theta and sine theta is greater than 0, also tan theta is less than 0. Remember, if we say something is greater than 0, something greater than 0, we're saying this is positive. If we say something is less than 0, that means something less than 0 is negative, right? So we'll check these two conditions. Sine is greater than 0, that means we're saying sine theta is positive. Tan theta is less than 0, that means we're saying tan theta is negative. So we have to check which quadrant will have sine theta being positive and tan theta being negative. So remember, this is your Cartesian plane. Here, all your trig ratios are positive. So sine theta is positive, cos theta is positive, tan theta is positive, like that. Here, only sine theta is positive, cos theta is negative, tan theta is negative. And then here, tan theta is the only one that's positive, sine theta is negative, cos theta is negative. Here, cos theta is the one that's positive, sine is negative, tan is negative. So we are gonna check from what we were given here. We were asked to find where sine theta is positive and tan theta is negative. So sine has to be positive. So sine is positive here and here. Tan is negative here. So that means our answer here is asking us which quadrant. So we're just supposed to say the second quadrant. Remember, our quadrants start like this. This is the first quadrant. This is the second quadrant. This is the third quadrant. This is the fourth quadrant. So the answer we are looking for is this one, second quadrant, and then we get that nice 2 marks. Any questions on that one?
No, sir.
All good. All right. Following question. We are supposed to determine without using a calculator the value of that. So immediately if they're gonna ask us that, they're asking us to remember our special angles, right? Asking us to remember our special angles. Okay, I think there was a table that I once did whereby I said sine, cos, and tan, like this. So if we have sine, we need the angles over there. Let's do this. You can find your own ways of remembering these. This is what I usually do. So if my angle is 0, if it's 30, if it's 45, 60, I think 90, and so on and so on. Right. So sine 0 is 0, I believe. This is 1 over 2. This is root 2 over 2. So root 2 over 2 is the same thing as 1 over root 2, like that. So if you know it like this, it's the same thing as that, right? To move from here to there, they use the method we called rationalizing. I think you'll explore that next year. And then sine 60 is just root 3 over 2. And then sine 90, I believe it's 1, like that. So those are the values for sine. For cos, you just take whatever that you ended with on sine, you start with it. So this will be 1. This will be root 3 over 2. This will be root 2 over 2. This would be 1 over 2. This would be 0, like that. All good. Then for tan, you just take whatever that's on top divided by this. So you're just going to have 0 over 1, which has to be 0. Have this over that, and then you're going to get 1 over square root 3. This over that, you're going to get 1. This over that, square root 3. This over that is undefined. So we just write that E over here for undefined because we don't have such a value. Right. So we will use these values. We'll use these values to solve this, right? Another thing that we have to remember, it's these extra functions. So if I'm given cosec, if I'm given sec, if I'm given cot. I remember saying something like this, that you count the third letter. So it's 1, 2, 3. This letter is S. That means this was 1 over sine theta or something like that. So third letter here, it's a C. That means this is 1 over cos theta. Third letter is T. This is 1 over tan theta, like that. Right. So let's look at that information and try to solve that. We have sine 45 times cosec 90 over, what do you have? All right, what do we have? What do we have? Square root 3 cos 0 tan 60. All right, so sine 45 is over here as square root 2 over 2. So it's square root 2 over 2, like that. And then cosec, it's going to be 1 over sine theta. So 1 over sine theta. Our angle here is 90, like that. Divided by square root 3. And then cos 0. So cos 0 is 1. And then tan 60 is square root 3. Like that. I have a feeling all of this is 0. Are we getting 0 so far? Hello? Oh, no, it won't be 0. That's fine. I hope not. All right. What do you get? Let me see. If you're going to punch in 1 over sine 90, what do you get? I have a feeling it's 0. 1 over sine 90, what do you get? One over sine 90. Is it a 0 or a 1?
It's a 1.
It's a 1. All right, I thought this was going to be a 0. So square root 2 over 2, that means this is 1 over square root 3 times square root 3. It's like this, squared. So this ends up being just 3. So that means this, all of this in the denominator is just 3. And then if you continue simplifying this, you're just going to end up with square root 2 over 2 times 3. This ends up being square root 2 over 6. And that's your answer. So your 5 marks over here, they're trying to see if you are able to convert these into their special numbers. And then from there, are you able to find your answer like that? So when they say without using a calculator, they are saying that they're not expecting this to be 3.4, 12, blah, 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 blah. They want it in this set form like that. Everything okay?
Sam, how did you find the square root of 2 over 2 times 3?
So from here, do you understand how we got here?
Yes, sir.
So here we are having square root 2 over 2 divided by 3, right?
Yes.
And then it's going to be square root 2 over 2 times 1 over 3. Are you okay there? Can you see it now?
Yes, sir. Yes, thank you, sir.
All right. And then that is the same thing as this, which leads to that. All right. Any other questions?
Hey, oof.
All right, the last question. Let's look at it. So we are told that if 13 cos theta is equals to -5, and theta is greater and equal or equals to 180 but less and equal to 360, we're supposed to determine using a suitable diagram and without the use of a calculator the value of cot theta, the value of sine squared theta minus cos squared theta. All right. So first things first, what you do when you get a question like this, you know you have to draw a diagram somewhere. You have to take this and make whatever trig ratio that you're given. If you were given sine theta, then you're gonna make sine theta the subject of the formula. If you were given tan theta, make tan theta the subject of the formula. So here I'm having 13 cos theta is equals to -5. For this to have cos theta as the subject of the formula, I can divide by 13 both sides like that. So I now have cos theta is equals to -5 over 13. Then after getting this to this point, I have to remember that my trig ratios for cos of an angle, this was the adjacent side over the hypotenuse. For the sine of an angle, this is the opposite side over the hypotenuse. For the tan of an angle, this is going to be the opposite side divided by the adjacent side, like that. Do we remember this?
Yes.
All right. So now, I think the diagram we normally use is this one. Okay, that's fine. So we now have to check which quadrant is theta in. So here, after simplifying and everything, we ended up with this sign over here, which is negative. That means we are saying the trig ratio we had, which was cos theta, is negative. So cos theta is negative on which quadrants? This is first, this is second, this is third, this is fourth. Which quadrants?
Fourth quadrant.
Fourth quadrant cos is positive. We were looking for where cos theta is negative. It's negative where?
On the third.
On the third, it's negative. Where else?
On the second.
On the second, it's negative. Right. So as you can see, we have two sections. That means our diagram can either be this side or that side. So that means there has to be another restriction that will help us narrow it down in terms of, are we going to draw it on the second or the third quadrant? This one is saying that theta has to be greater than 180. So if we're going to plug in numbers, this is 0, this is 90, this is 180, this is 270, this is 360. So we're saying that our theta angle has to be greater than 180. That means from 180 going that side, it cannot be this side. So that means this one is out. We are expecting our diagram to be on the third quadrant. Does that one make sense?
Yes, sir.
Yes. Yeah.
So now we know our diagram is on the third quadrant. So we draw our diagram. Third quadrant, this is my diagram over here, like this. My angle is always measured from here, coming this side. That's my theta. And then from there, we said this was adjacent over hypotenuse, right? So which side is adjacent to theta here? Is it 1 or 2 or 3?
Two.
It's 2. Adjacent means next to. And it cannot be this one because this one is the hypotenuse. So that means if we are saying it's 2, we'll take whatever we had on our numerator, which was 5. We'll have 5. And then on the denominator, we had 13, which is our hypotenuse. This is our hypotenuse. But we have this sign over here, which is a minus. Does that minus belong to the hypotenuse or the adjacent side?
To the adjacent side.
Adjacent.
It belongs to the adjacent because our hypotenuse cannot be negative, right? So which side are we missing, the x or the y side?
The y.
The y. So the y, remember the y's are the verticals. So that's our y, that's our x. We do have an x, we're looking for the y. Are we expecting the y value to be positive or negative?
Positive.
Negative.
Negative. Sorry.
Negative.
Negative.
Positive values are here. These ones will be negative. So we now have this triangle over here, right angle triangle. We're trying to solve for y. Which theorem are we going to use?
Theorem of Pythagoras.
Theorem of Pythagoras. So it will be r squared, x squared plus y squared, like that. And then our r is 13
squared.
equals to minus 5 all squared plus y squared.
Y squared.
This is 169, I think, equals to 25 plus y squared. This is 169 minus 25 equals to y squared. So our y squared, it's equals to, I think it's 144, like that. And then remember, this is squared. We are looking for y, not y squared. So plug in our square root. We said whenever we plug in your square root, here I need a plus minus. I want to see my plus
Y
minus.
equals to 12.
Negative 12. Right.
Plus minus 12. So that means we'll use negative
12.
12.
for where our diagram was positioned. So if our diagram was on this quadrant over here, if it was on the second quadrant like that, which y were we going to use? Positive.
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 Mhm.
Like that. Right. So now we have found all our sides. Said here it's going to be negative 12, like that. So now we have all our sides. So they're asking us to find the value of cot theta, sine theta minus, what's this? Cos squared theta, right? So our x value, it's negative 5. Our y value, it's minus 12. Our r is 13, right? So in this case, our x value counts as our adjacent. Our y value counts as our opposite. Our r counts as our hypotenuse. Right. Remember, cot, it's 1, 2, 3. That means we are looking at the inverse of, so even the inverse, the reciprocal of tan. So that means it's just 1 over tan theta. That's what we are looking for, right? So remember, for tan theta, it was just gonna be y over x. This 1 over makes you flip these two like this. So the numerator becomes the denominator becomes the numerator. So you end up with x over y. This is the same thing as cot theta. Is everyone okay here?
Yes, sir.
Okay.
Yes.
So that means our cot theta is just going to be x over y. Our x value, we know it as minus 5. Our y value, we know it as minus 12. So this is just 5 over 12, like that. Those negatives will cancel each other. So we are done here. So as you can see, here you're given extra marks for all of these diagrams and what. So they want to see where you started from here, simplifying this, and then from there finding the right quadrant and drawing your diagram. the Pythagoras theorem, and then getting the right value, whether it's the positive or the negative one, and then substituting. So this substituting part over here could just be 1 mark. Whereas all the other marks are from this method that you have used. All right. The last one is asking us to find the value of sine squared theta minus cos squared theta, like that. So sine squared, we know that sine, we know it as opposite over hypotenuse. So we are squaring it now, minus cos, we know it as adjacent over hypotenuse, we square it. So the opposite side over here, we said it was 12, negative 12 over 13. You square it like that. So I'd advise you that every time you substitute values, put them inside brackets. Because if you're gonna have minus 12 squared and minus 12 all squared, this will give you negative 144. This will give you positive 144. This is the one we want. This will give you the wrong answer. All right, there's a squared somewhere there. And then we have for cos adjacent, it's minus 5 over 13 squared. So this will give me 144 over 169 minus 25 over 169. So these are fractions. I cannot add or subtract if the denominators are not the same. So my denominator is 169 and 169. So I can just say 144 minus 25 divided by 169. What's 144 divided by 25? (144) divided by 25, not divided, minus 25.
(119)
119 over 169. If you can still simplify this further, go on. If not, you leave it like this. Because they're not expecting you to know that this is 0. Blah, 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 like that. So you leave it like that. All right. Any questions regarding this?
No, sir.
All right. We'll continue.
No,
We'll continue tomorrow then with this type of questions. Hopefully people are gaining something.
Yeah.
Thank you,
Alright.
sir.
Thank you, sir.
Sure.
Bye.